When a hurricane hits, we tend to think the biggest danger is the storm itself, right? The wind, the rain. But what if the real threat is what happens after? Today, we're going to dig into a whole new way of thinking about building for survival, and it all boils down to a single, massively overlooked factor.
Now this quote, it doesn't come from some scientist in a lab or a politician at a podium. It's from someone who spent 20 years on the ground actually rebuilding after disasters. And they're arguing that our obsession with strength has made us totally blind to a much bigger vulnerability. So let's unpack what that really means.
All right, so let's get right into it. The fundamental problem is that the building methods we've trusted for decades were designed for a climate that, just doesn't exist anymore. The storms we face now are more intense, they pop up faster, and the old rulebook, well, it's just not working. To really understand this, you have to see it in the real world. I mean, we talk about damage, but sometimes it's so much worse. After Hurricane Melissa tore through Jamaica, the author of our source material saw whole neighborhoods that were just gone, wiped off the map. That's what happens when our building systems can't keep up with reality. And the cost? Wow, we're talking staggering amounts of money. A single storm hitting just one country caused almost $9 billion in damage. Now imagine scaling that up globally. You start to see why this isn't just a construction issue, it's a massive economic crisis waiting to happen.
But here's the thing. The storm itself, that's just the start of it. The real, kind of hidden danger is actually in the recovery process. This is where we uncover that vulnerability we talked about, the one that's way less obvious than high winds or floodwaters. And this brings us to this really critical idea called the exposure gap. Think of it as the time after the storm is passed, but before a community is safely rebuilt. Every single day that gap stays open, families are left exposed to the next storm, to chaotic supply chains, and to the unbelievable stress of being forced out of their homes.
So, you've got this dangerous gap. How do you close it? Well, it looks like we're faced with two really different paths forward. On one side, you have a modern, systems-based way of building, and on the other, you have traditional concrete. The choice between them pretty much determines how long a whole community stays at risk.
And when you look at the timelines, the difference is it's absolutely staggering. A home built with a modern system can be up and ready in 3 to 6 months. A traditional concrete building, that can take 1 to 2 years. That's potentially 2 full hurricane seasons that a family is left without a safe place to live.
Now let's be fair. Concrete is strong. We all know that. It's familiar. For years, it's been the go-to for building tough structures. But in the world we live in now, its biggest weakness isn't its strength at all. It's the unbelievable amount of time it takes to build with it. You see, that 1 to 2 year timeline isn't just a waiting game. It's a period of constant, active risk. The project is wide open to another storm, to supply chain nightmares, to labor shortages, to costs spiraling out of control. And the whole time, the community that so desperately needs these homes remains scattered. And that really gets to the heart of the whole argument, right? The failure of concrete in a disaster zone isn't about a crack in a wall. It's about the 18 months a family has to wait for that wall to even exist, leaving them totally exposed in the meantime.
So this all leads us to a pretty big question, doesn't it? If we can all agree that speed is now a vital part of being resilient, what's the solution? How do we manage to build something that's both strong and fast?
Well, the answer seems to lie in a big shift in thinking, moving away from just focusing on materials and toward building with integrated systems. A great example of this is something called structural insulated panels, or SIPs. You got to think of it less like stacking bricks and more like assembling a high-performance machine.
One of the biggest differences is where the actual building components are made. SIP systems are engineered with incredible precision inside a controlled factory. This just eliminates all the chaos and uncertainty you get on a typical job site. The bad weather, the inconsistent work, the material delays that can just kill a concrete project. It's all about controlling the process to reduce the risk.
And it's not just about the process, right? The performance is a whole different ballgame. A SIP structure gives you a perfectly sealed, super insulated building envelope all in one go. Now compare that to a concrete wall, which needs all these different layers for the structure, the insulation, the weatherproofing, and every single one of those layers is a place where something can go wrong.
Okay, so that all sounds pretty good on paper, but you're probably wondering, does this stuff actually work in the real world when things get ugly? Let's look at the data and see how this systems approach actually performs when a real storm hits. The data is pretty incredible. After Hurricane Sally, researchers looked at homes built to this rigorous, systems-based standard called Fortified. And what they found was that these homes were over 70% less likely to even file an insurance claim. That is a massive difference. It proves this approach actually prevents damage before it even happens.
And this really shows us that true resilience isn't just about having a thick wall. It's about the entire building working together as a single system, one that can manage wind pressure, control temperature, black out moisture, and maintain a continuous, unbroken structure from the roof all the way down to the foundation.
So when you put all this together, it really forces you to take a step back and just completely reframe the whole conversation. It means we have to start asking a totally different, and frankly, a much better question.
And this is it. The big question is no longer what's the strongest material. The question we have to ask now is, how fast can we rebuild permanent protection? That one change shifts the entire focus away from just brute strength and onto the speed of getting a family back into a safe home.
So in the end, what's the big takeaway here? It's that time itself has become the most critical building material we have. It is the one resource we absolutely cannot afford to waste in between these storms. And the building methods we choose don't just decide how strong our homes are, they decide how fast they can become homes again.